Hi, I'm Arafa Farahmandi, and I'm PhD student of neuroscience at Queen's University. I've been TA for 3 years in Neuromatch Academy, and today I want to discuss linear regression and different multiple and polynomial linear regression of that. So let me share my screen and just go to the tutorial. Okay, so linear regression is a model that can help us to figure out the relation between different data points. So if we have a problem that we want to see if there is a linear relationship between y data points and x data points, we would use one equation, which is y equal to theta x. And after that, we would use MSE and calculate that to figure out the exact value of theta that can help us to figure out the exact relationship of x and y. But in multiple linear regression, we have a bit different scenario. It means that in this kind of problem, we have different features, and we want to see if there is a relationship between y as an outcome or any kind of, a different or different kind of data as as a function of different features that we have. So we call different features as x1, x2, x3, and all of those are different data points which are related to specific feature. And now in this scenario, we have different theta that is specifying each feature that we have. So the overall equation would be like this. And we have, again, the bias term as we had it in linear regression. So what does it mean? Sometimes we need a bias or a constant value to be added to our relationship to map exactly the line on the data point that we want to consider. So we have theta 0 and we have this column 1 here in our X matrix that can help us to estimate a specific constant value in theta if needed. So here we use OLS we use OLS for our analytical solution to calculate the theta. Here okay, let's calculate that. So theta hat would be the inverse of this matrix, and we use NumPy and linear algebra to calculate the inverse of matrix, which is the transpose of x multiplied by x itself. And after that, it should multiply by transpose of x again, multiplied by y. And we can check the values with the answers here. After that, we want to go to polynomial regression. So polynomial regression is a different scenario. What does it mean? It means that sometimes the relationship between x and y is not linear. So it means we need more complexity. We need more degree of freedom. So we are adding some different features that can give us this freedom to have curvature in the relationship. So what does it mean? It means that we use different degree of x, like x to the power of 2, x to the power of 3. So it gives us this kind of flexibility to add the complexity for this relationship to help us map all of those data points that we have as the features. So here in our design matrix or the input matrix, we call input matrix in polynomial regression as design matrix, which include different degree of x to the power of 0, x to the power of 1, x to the power of 2, and a lot of different degrees if needed in our mapping. So we have another simulation here to generate this data, and we need a curvature for mapping all of these data points. So this is our design matrix. It is x to the power of different degrees. So exactly we need that here to calculate design matrix. Yeah, and after that we have our design matrix. And also